Hi guys, welcome to part 1 of a video series where we're looking at how to integrate using U-substitutions. I'm going to start off with a relatively simple example, the integral of 10x multiplied by x squared plus 25 to the 10 with respect to x. Now, U-substitution is a useful tool whereby we take an integral that is otherwise quite difficult, and by introducing a second variable, which is u, we are able to eliminate enough terms that it's not too difficult to do. Then we substitute back in at the end. Now, with U-substitutions, normally you can see which of these terms you let equal u. Now we're going to let this complicated term here be the u term. Now you need to be thinking about differentiating this and the consequences of that. So the u bracket here is easily differentiable. So we're going to I'll write down here u is equal to x squared plus 25. Now we want to differentiate u with respect to x. And we want it in terms of dx so that we can substitute that in for this dx term. So we are going to rewrite it as follows. And now we can take this substitution and this substitution and pop them into the original equation. So the 10x stays, and now if I move this down, instead of writing x squared plus 25 to the 10, we can simply write u to the 10. And instead of the dx, as I mentioned, we just drop in the du over 2x. Now the common tool of the U-substitution is that looking at this you think, wow, how can we integrate with respect to x when we're only integrating with respect to u? Well, what happens if you've done this correctly is that you'll be able to cancel the terms out. So we simply have and I'm sure that you all know that that integrates to 5u to the 11 over 11 plus c. However, that's not the end of the question, because we still have to substitute and get it back in terms of x as it was originally in the original question. So if you remember that u was equal to x squared plus 25, we simply drop that back in and we have our answer. Plus a constant. Thanks for watching. Be sure to check out part 2 of this series for a slightly more complicated trigonometric version. Thanks.